A pleasant day, everyone. First of all, I'm John Tabago,
And I'm Adjutor El Gama.
and we are here to discuss our topic with regards to engineering data analysis. And here's the following chapter to be discussed.
The first chapter is Chapter 7, Statistical Interval. Chapter 8, Test of Hypothesis for a Single Sample. Chapter 9, Statistical Inference of Two Samples. Chapter 10, Simple Linear Regression and Correlational. And the last is the Chapter 12, Design Analysis of a Single Factor Experiment.
The first chapter that we need to discuss is Chapter 7, which is a statistical interval.
First, what is statistical interval? It represents an uncertainty that exists in the data because we work with samples that are obtained with a larger population or process. As the number of the sample we have to work with increases, we notice that the length of a confidence interval decreases. A confidence interval single sample. Confidence interval, or denoted by CI, is an interval of values constructed so that with a specified degree of confidence, the value of population parameter lies in this interval.
In the other, a confidence interval is the mean of your plus and minus to the variation in that estimate. In frequency statistic, a confidence interval is a range of estimate for an unknown parameter. A confidence interval is computed at a designated confidence level. The 95% confidence level is the most common, but other levels such as 90% or 99% are sometimes used.
Second is the confidence coefficients, denoted by C. Is the probability that the confidence interval encloses the population parameter in repeated sampling.
The confidence coefficient is simply the proportion of the sample of a given size that may be expected to contain the true mean. That is, for a 95% confidence interval, if many samples are collected and the confidence interval computed in a long run, about 95% of these intervals would contain the true mean.
Confidence interval single sample. What is confidence level? Is the confidence coefficients expressed as percentage. These are the common confidence level that we use. 90% confidence is equivalent to z sub alpha all over 2 is equal to z sub 0.05 is equal to 1.645, and 95% confidence is equivalent to z sub alpha all over 2 is equal to z sub 0.025 is equal to 1.96, and 99% confidence is z sub alpha z sub alpha all over 2 is equal to z sub 0.005 is equal to 2.576. The probability that the selected z value is between negative 1.96 and positive 1.96 is 95%. P, the quantity of z, is greater than 1.96 and z is less than 1.96 is equal to 0.95.
This value come from our understanding of the standard normal distribution. To illustrate, we will consider 95% confidence.
This general graph that can be used for any confidence level would look like this: how we set up the error and confidence level. The alpha all over 2, it represents the area of shaded region, and the negative z sub alpha all over 2 and the positive z alpha all over 2, it represents the confidence level, and or the 1 minus a in this middle part. And we have given formula P, quantity of z greater than or equal to negative z sub alpha all over 2, and the z less than or equal to z sub alpha all over 2 is equal to 1 minus alpha.
The central limit theorem, or CLT. tells us that as the sample size n increases, the sample mean x is close to normally distributed with expected value mu and standard deviation q over square root of n. Standardizing x first subtracting its expected value and dividing by its standard deviation yields the standard normal distribution. So here's the formula of CLT, or the central limit theorem. The central unit theorem states the sampling distribution of a sample mean is approximately normal if the sample size is large enough. Even if the population distribution is not normal, we need to subtract its expected value first, then divide into the standard deviation, which is the normal variable.
Confidence interval on the mean of a normal distribution variance known. From sampling distribution L and U, P, the quantity of mu is greater than or equal to L and mu is less than or equal to U is equal to 1 minus alpha. Indicates probability of 1 minus alpha that confidence interval will contain the true value of mu. After selecting the sample and computing L and U, the confidence interval for mu is greater than or equal to L or mu is less than or equal to U. L and U are called the lower and the upper confidence limit. Suppose x sub 1, x sub 2, and x sub n is a random sample from a normal distribution. Z has a standard normal distribution. This is the formula of the normal standard distribution. Z is equal to x bar minus mu all over to sigma all over square root of n. Writing the z sub alpha over 2 for the z value. Hence, P is x bar minus mu all over to sigma all over to square root of n is greater than or equal to negative z sub alpha all over 2 and x bar minus mu all over to sigma all over to square root of n is less than or equal to z sub alpha all over 2 is equal to 1 minus alpha. Multiplying each term is mu is greater than or equal to x bar minus z sub alpha all over 2 sigma all over square root of n, and mu is less than or equal to x bar plus z sub alpha all over 2 is sigma all over square root of n. A 100 times 1 minus alpha percent confidence interval or on mu when variance is known. Pumunta naman tayo sa unang example ng ating lesson. Example, a confidence interval estimate is desired for the gain in a circuit on a semiconductor device. Assume that a gain is normally distributed with standard deviation of 20. Find a 95% confidence interval for mu when n is equal to 10 and x bar is equal to 1000. 95% confidence interval for a confidence level for alpha is equal to 0.5 comma z sub 0.05 all over 2 is equal to z sub 0.05 all over 2 is equal to 1.96 confidence level. Now, given yung mga values na n is equal to 10 at sigma is equal to 20 at yung x bar is equal to 1000 at yung sample yung z is equal to 1.96, meron tayong formula na gagamitin. Ito, input lang natin lahat ng values dito sa formula. Makukuha natin is 9 is mu is greater than or equal to 987.6 at sa kabilang side naman is mu is less than or equal to 1.11 mu is equal to less than or equal to 1212.4. Ito na po yung answer. Punta na tayo sa susunod. A confidence interval single sample ulit. Margin of error formula. Ito yung margin of error formula. E is equal to G sub alpha all over 2 times sigma all over square root of n is equal to Z times sigma all over square root of n. Thus, the confidence interval is x bar positive or minus E. The confidence interval is centered at the sample mean x bar and extends 1.96 times sigma all over square root of n to each side of x bar. The interval's width is 2 times 1.96 times sigma square all over 2 square root of n, which is not random. Only the location if the interval random its midpoint or midpoint or x bar. Ito yung sinasabing midpoint, yung x bar dito.
The formula for margin of error is calculated by multiplying a critical factor or, or for a certain confidence level with the population standard deviation, and then the result is divided by the square root of the number of observation in the sample. Margin of error is a statistical expression that is used in order to determine the percentage by point which the result arrived will different from the value of the real population, and it is calculated by dividing the standard deviation of the population by the sample size, and lastly multiplying the resultant with the critical factor.
Next, confidence interval of single sample pa rin. Interpreting a confidence interval. We are 95% confidence that the true parameter is in this interval. A correct interpretation of 95% confidence relies on the long-run relative frequency interpretation of probability in repeated sampling. 95% of confidence interval obtained from all samples will actually contain mu. The other 5% of the intervals will not. The confidence level is not a statement about any particular interval, instead of pertains to what would happen if a very large number of light intervals were to be constructed using the sum confidence interval for formula.
So here's our example. A random sample of 65 Hollywood movies had a mean length of 115.2 minutes. Suppose the population standard deviation is 11.7 minutes. Construct a 95% confidence interval. So we can use this formula. E is equals to Z, the quantity of sigma, all over the square root of n. So our sigma is equals to 11.77, and our n is the 65 rather. At ang nakuha nating sagot ay 2.844. Tapos ang sunod ay ang x sub bar, which is 115.2 plus 2.844, at nakuha natin ang 118.044. At ang sunod natin ay pagmamainasin natin sila. Tulad ng 115.2 minus 2.844, at nakuha natin ang 112.356. Interpret the interval. We are 95% confident that the population mean length of Hollywood movies is between 112.356 and
Dito pa rin tayo sa confidence interval single sample. To avoid the error involved in replacing sigma by s, we will introduce a new random variable, the t-distribution. Let x sub 1, x sub 2, x sub n be a random sample from a normal distribution with unknown mu and sigma squared. The random variable formula is t is equal to x bar minus mu all over s all over square root of n. As a t-distribution with n minus 1 depth of field, Number of depth of field is the number of observation that can be chosen freely. Also called student's t distribution, similar in some respect normal distribution, flatter than the standard normal distribution. Mu is equal to 0 and sigma square is equal to k all over to the quantity of k minus 2. The t distribution table 4 provides percentage points of the t distribution. Let t sub alpha comma k be the value of the random variable t with k quantity of depth of field. Then the t sub a comma k is the an upper tail 100 alpha percentage point of the t distribution with k. At ang figure nito is yung t distribution. Yung alpha is yung shaded area of shaded region at itong space dito is yung confidence interval. The t confidence interval on mu, a 100 times 1 minus alpha percent confidence interval, the mean of a normal distribution with unknown of sigma square. We have formula mu is greater than or equal to x bar minus t sub alpha all over 2 comma n minus 1 and s over square root of n, and mu is less than or equal to x bar plus t sub alpha all over 2 comma n minus 1 s all over square root of n. T sub alpha all over 2 and n 2 comma n minus 1 is the upper 100 alpha 100 alpha all over 2 percentage point of the t distribution with n minus 1 depth of field. Now, dito na tayo sa example ng t distribution. Example, an IZOD impact test was performed on 20 specimens of PVC pipe. The sample mean is 1.25 and the sample standard deviation is S is equal to 0.25. Find a 90% lower confidence bound on IZOD.
99.
99% lower confidence bound in IZOD impact strength. Ito yung solution. Find the value of T sub alpha over 2 comma n minus 1. Given A, alpha is equal to 0.01 and n is equal to 20, then the value of T sub alpha over 2 n minus 1 is equal to 2.878. Ito yung formula na ating gagamitin. Input lang natin yung values na nakuha natin. Mu is greater than or equal to 1.25 minus 2.878 yung nakuha natin dito times 0.25 all over square root of 20. Ang makukuha natin dun sa part nito, sa left part is 0.4 ay mu is greater than or equal to 0.445. Kabila naman, mu is less than or equal to 1.25 plus 2.878 times 0.25 all over square root of 20. Ang makukuha naman natin dito sa right part is mu is greater than or equal ay less than or equal to 2.054. Ito yung sagot na makukuha natin sa solution na to, example na to. Now, dito na tayo sa last subtopic ng chapter nito, T-square distribution. Sometimes confidence interval on the population variance is needed basis of constructing this confidence interval. Let x sub 1, x sub 2, x sub n be a random sample from a normal distribution with mu and sigma square. Let s square be the sample variance. Then the random variable formula is x square is equal to the quantity of n minus 1 times the s square all over the sigma square as a t-square of x square distribution with n minus 1 depth of field. One-sided confidence interval. A 100 times 1% lower confidence bound or upper confidence bound on sigma square. Sigma square is greater than or equal to the quantity of n minus 1 times the s square all over the x square sub alpha minus n minus 1, and sigma square less than or equal to the quantity of n minus 1 times the square s square all over the x square sub 1 minus alpha comma n minus 1. Confidence interval or the variance normal population. A 100 times 1 minus a ay 1 minus alpha percent confidence level on sigma square. So yung formula, sigma square is greater than or equal to the quantity of n minus 1 s square all over the x square sub alpha all over 2 comma n minus 1, and sigma square is less than or equal to the quantity of n minus 1 s square all over the x square sub 1 minus alpha divide all over 2. Ay, ulit. Sigma square is less than or equal to the quantity of n minus 1 s square all over 2 x square sub 1 minus alpha sub 1 minus alpha all over 2 comma n minus 1. X square sub alpha all over 2 comma n minus 1 and x square 1 minus alpha all over 2 comma n minus 1 are the upper and lower 100 alpha over 2 percentage points of the chi-square distribution with n minus 1 degrees of freedom. Example nitong chi-square is a rivet to be inserted into a hole. A random sample of n is equal to 15 parts in selected, and the hole diameter is measured. The sample standard deviation of the hole measurement is s is equal to 0.008 millimeters. Construct a 99% lower confidence bound for sigma square. Solution for alpha is equal to 0.01 and x square sub 0.01 comma 14 is equal to 29.14. Now, yung formula kanina nakita natin, gagamitin natin yan at substitute lang natin yung mga values dito. Ang nakuha natin is sigma square is greater than or equal to 14 times 0.008 square all over 29.14. Ang makuha nating sagot dyan pag ninput natin sa computer is sigma square is greater than or equal to 0.00003075.
At the end of this discussion, you'll need to memorize our objective at this topic and all of the formulas to know how to construct an confidential interval.
Lahat po ng formula na ating napag-aralan sa una hanggang sa huli ditong sa chapter 7, kailangan nating memorize. At yun po nagtatapos ang aming report sa chapter 7.
Salamat po.
Salamat po.